Hi everyone, welcome back. In this video, we are going to learn 8.4 Applications of Kinematics of Linear Motion. Solve the kinematic problem of linear motion involving differentiation and integration. We have learned all the concepts involved in this chapter, and in this video, we are going to do more problem-solving questions later. Before that, let's do some revision. If you are given a displacement function and the question asks you to find velocity function, then v equals to ds dt. We do differentiation. Whereas if you are given a velocity function and the question asks you to find displacement, then we perform integration. S equals to integrate v dt. Next, if you are given a velocity function and the question asks you to find acceleration, then we do differentiation. A equals to dv dt. Whereas if you are given acceleration function and the question asks you to find velocity, then we do integration. V equals to integrate a dt. You can also have a look at this diagram to have a better idea. From S to V, we do differentiation. From V to A, differentiation. From A back to V, integration. From V back to S, also integration. Let's try some questions. Example 36. Fariza starts running along a straight lane for 30 seconds from a starting point. Her velocity is given by v equals to 0.9 t minus 0.03 t squared, where t is in between 0 to 30. Find the time in seconds when her acceleration is 0. So we are given velocity function, and they mention about acceleration. From v to a, we have to do differentiation. So after we differentiate, we have 0.9 minus 0.06 t. The question said a is 0, so I let a equals to 0. So we have answer t equals to 15. B, find the distance traveled by Fariza in meter. If you would like to confirm whether Fariza changes direction or not halfway within 30 seconds, you can do v equals to 0. So I do v equals to 0. 0.9 t minus 0.03 t squared equals to 0. I factorize out t, then we have answer t equals to 0 and t equals to 30. So now we are very sure that Fariza didn't change direction before t equals to 30. So if you would like to find distance traveled, you can integrate 0 to 30 straight away for integration of v dt. Okay, let's check. Why I do integrate v dt here is because displacement function is not given. Okay, when you don't have a displacement function and you would like to find distance traveled straight away, you can do integrate v dt in your working. Okay, so now I sub v equals to 0.9 t minus 0.03 t squared. Okay, then we integrate. I simplify, then we sub 30 into the function minus sub 0 into the function. So we have answer 135 meter. Example 37. SNK Seri Aman launched a water rocket in a school field during the officiating ceremony of the Mathematics and Science Carnival. The rocket was launched vertically upward from the surface of the field, and velocity is given 20 minus 10 t. The rocket stops momentarily at p seconds. A, find the value of p. So let's check. The rocket stops momentarily at p seconds. That means when v equals to 0, t equals to p. And velocity function is given 20 minus 10 t. So we do substitution. V we sub 0, t we sub p. So we have 20 minus 10p equals to 0. Then we get p equals to 2. B, express the displacement of the rocket at t seconds. So from velocity function, if you would like to obtain displacement function, we have to do integration. So S equals to integrate v dt. So integrate 20 minus 10t dt. Then we will have a plus c at the back. So let's check the information given. The rocket was launched vertically upward from the surface of the field. Okay, let's recall. Previously in other question, we see this sentence very often. A particle moves along a straight line and passes through a fixed point O. That means the particle starts moving at fixed point O. That means when t equals to 0, s equals to 0. So usually the particle moves horizontally. Whereas for this question, they said the rocket was launched vertically upward. So when the rocket was launched, that means t equals to 0. Launch vertically upward from the surface of the field. So that means now the surface of the field is s equals to 0. That means when t equals to 0, s equals to 0. So that's why I substitute the value here. T we sub 0, s we sub 0. So in the end, we have c equals to 0. So we have a displacement function, s equals to 20t minus 5t squared. C, determine the maximum height of the rocket. Okay, so since the rocket was launched vertically upward, that means the maximum height in this question means maximum displacement. For maximum displacement, ds dt equals to 0. So that's why I do ds dt equals to 0, and ds dt is v. Okay. When v equals to 0, I can refer to part A. I notice that when I continue the working, I will have t equals to p, and p is actually 2. That means t equals to 2. When v equals to 0, t equals to 2. So I straight away write down here, t equals to 2. And the meaning of 2 is, this is the time in which the height is maximum. So to get back the value of maximum height, I substitute t equals to 2 into the displacement function. So here we sub 2, here we sub 2. Then we have answer maximum height equals to 20 meters. After that, please prove that the height is really maximum by doing d2s dt squared. So let's check. ds dt is v. So v, this is actually ds dt, 20 minus 10t. And now you want to do d2s dt squared. That means you have to differentiate velocity function. So after we differentiate, we have answer negative 10. When d2s dt squared is a negative number, that means you prove already the height is a maximum. C2, determine the time when the rocket touches the surface of the field. Surface of the field means s equals to 0. So we let s equals to 0. And this is the displacement function, 20t minus 5t squared equals to 0. Then we just factorize out the common term. We have t equals to 0 or t equals to 4. The time when the rocket touches the surface of the field again will be t equals to 4. Example 38. The diagram shows the positions and directions of two boys, Far East and Qian Hao, running on a straight path, each passing two fixed points, P and Q at the same time. Far East stops instantaneously at point R. The velocity of Far East is given by v equals to 6 plus 4t minus 2t squared, while Qian Hao runs with a constant velocity of negative 5 meters per second. It is given that the distance of PQ is 50 meters. Okay. Assume motion to the right is positive. Let's do a quick revision. Previously, we learned that when a particle moves to the right, velocity is greater than 0. When a particle moves to the left, the velocity is less than 0. Then let's check. The velocity of Qian Hao given is negative 5. That means Qian Hao moves to the left. That means we can identify that he is Qian Hao. Okay, then this is Far East. A, calculate the maximum velocity of Far East. So let's check. The velocity function of Far East given is v equals to 6 plus 4t minus 2t squared. For maximum velocity, we have to do dv dt and let it be 0. So based on this velocity function, let's do dv dt first. So after differentiation, we have 4 minus 4t. And then let dv dt equals to 0. We have 4 minus 4t equals to 0. So we have t equals to 1. So t equals to 1 is the time in which velocity is maximum. So to find the value of maximum velocity, we need to sub t equals to 1 back to the velocity function. So we sub, after that we have maximum velocity is 8 meters per second. Next, please prove that the velocity is really maximum by doing second order derivative. So let's check, this is dv dt, 4 minus 4t. Then we have to differentiate it one more time. We will get negative 4. So d2v dt squared is negative 4. That means less than 0. That means we prove already v is a maximum. B1. Sketch a velocity time graph for far east from point P to point R. Let's check the question. Far east stops instantaneously at point R. That means for far east at point R, v equals to 0. So this is the velocity function. Let's try v equals to 0. So 6 plus 4t minus 2t squared equals to 0. Since I noticed that a is negative, so I bring all the term to the right. So that's why we have 2t squared minus 4t minus 6 equals to 0 here. Then I divide every term by 2. Then we do factorization. Then we have answer t equals to 3. So let's check what's the meaning of t equals to 3. When v equals to 0, t equals to 3, that means far east stops at point R at t equals to 3. Then let's check the question. You are required to sketch a velocity time graph for far east from point P to point R, and at point R, t equals to 3. That means the range of time that you have to plot later is from 0 to 3. Next, let's look at the velocity function. V equals to 6 plus 4t minus 2t squared. So a is negative 2. When a is negative, you know you have to draw an N-shaped parabola later. Okay, so to draw a parabola, you need x-intercept, y-intercept, and a maximum point. So let's check what we had just now. For velocity time graph, x-coordinate is t, y-coordinate is v. So just now we have when t equals to 3, v equals to 0. That means you already have x-intercept 3, 0. And then from part A, we have already found maximum velocity. Okay, when t equals to 1, v equals to 8. So we have maximum point 1,8. That means you just need to find y-intercept. For y-intercept, we have to do at y-axis, x equals to 0. For this question, we have to do at v-axis, t equals to 0. That's why we have to sub t equals to 0 into the velocity function, and we get v equals to 6. That means we need to plot 0, 6 into the graph. So with these 3 points, you can sketch the velocity time graph. Then find the distance traveled by far east from point P to point R. For far east, velocity function is given. V equals to 6 plus 4t minus 2t squared. But we didn't find displacement function at all just now. So now, to get the distance traveled, we have to do integrate v dt. Okay, then let's check. Point P is the starting point. So at point P, t equals to 0. At point R, t equals to 3. So we integrate from 0 to 3, v dt. So v is 6 plus 4t minus 2t squared. We sub here. Then we do integration. Then we sub 3 inside the function minus sub 0 into the function. So we have answer distance traveled is 18 meters. C. Determine the distance between far east and Qianhao when far east is at point R. Okay, when far east is at point R means when t equals to 3. So let's do some working for Qianhao. Qianhao runs with a constant velocity of -5. That means the velocity function of Qianhao is -5. From velocity, if we want to get distance, we have to firstly identify the displacement function. So from v, I want to do s. So s equals to integrate v dt. So equals to integrate -5 dt. Don't worry, we can integrate a number, then the answer is -5t, and we have a plus c at the back. So let's check. In the beginning of the experiment, Far East is here, and this is s equals to 0, and then PQ is 50 meters. So that means in the beginning of the experiment, the S for Qianhao is S equals to 50. So for Qianhao, when T equals to 0, S equals to 50. So after I sub, we have C equals to 50. That means the displacement function for Qianhao is S equals to -5t plus 50. Then let's check. When Far East is at point R means when T equals to 3. So I sub T equals to 3 into displacement function of Qianhao. We have S3 equals to 35. Okay, that means when T equals to 3, Qianhao is somewhere here, 35 meters, S equals to 35. Then, where is Far East? We already identified just now. The distance traveled by Far East from point P to point R is 18 meters. Okay, so from the beginning until T equals to 3, the distance traveled is 18 meters. So that means when T equals to 3, for Far East, the displacement is S equals to 18. So Qianhao is at S equals to 35. To find their distance, we just do minus. So distance equals to 35 minus 18, we have 17 meters. Example 39. Azim runs along a straight path from a fixed point O. His velocity after passing through O is given by V equals to mt squared plus nt. Azim stops to rest after running half of the distance when t equals to 1 with an acceleration of 12.5 km per hour. Azim stops means V equals to 0. So the whole sentence here, they are telling us when V equals to 0, t equals to 1, and a equals to 12.5. Assume motion to the right is positive. A, find the value of m and of n. First of all, let's check the function given. We are given a velocity function, v equals to mt squared plus nt, and the information related to velocity is Azim stops at t equals to 1. When Azim stops, v equals to 0. So we sub t equals to 1 and v equals to 0 into the velocity function. Then we have an equation m plus n equals to 0. That means n equals to -n. Next, let's check what else. Here we notice that when t equals to 1, a equals to 12.5. So to make use of this information, you must firstly obtain an acceleration function. So from v, if I want to get a, I have to do differentiation. So we differentiate mt squared, answer to mt, differentiate nt, answer n. So I substitute when t equals to 1, a equals to 12.5. So t I sub 1, a I sub 12.5. We have another equation, 12.5 equals to 2m plus n. So I do simultaneous equation for these two equations. Whenever I see n, I sub -n. So we have answer m equals to 12.5. So n equals to -12.5. B, find the minimum velocity of Azim. For minimum velocity, dv dt equals to 0. Before that, let's subtract the value of m and n into the velocity function. By doing so, we have velocity function v equals to 12.5 t squared minus 12.5 t. Then only we apply for minimum velocity dv dt equals to 0. dv dt is a. And we also have acceleration function just now. So let's sub m and n into the acceleration function also. Then we have a equals to 25t minus 12.5. Then we let it be 0. We will have t equals to 0.5. So this means when t equals to 0.5, minimum velocity occurs. So to get the answer for minimum velocity, we have to sub t equals to 0.5 into the velocity function. So we have answer negative 3.125 km per hour. After that, please prove that V is really minimum. So let's do d2V dt squared. dV dt is 25t minus 12.5. So we differentiate it one more time. We will have 25, which is positive. When d2V dt squared is greater than 0, that means V is a minimum. C. Find the distance traveled by Azim in a second hour. There are two different methods to solve this question. The first method is we try to get displacement function first. So for displacement function, it is equals to integrate V dt. V is 12.5t squared minus 12.5t. So I sub here. Then we do integration. After that, there is a plus C at the back. So let's check. Azim runs along a straight path from a fixed point O. That means Azim starts running from a fixed point O. That means when t equals to 0, s equals to 0. So we sub t0, s0. Then in the end, we have c equals to 0. So this is the displacement function. After that, we read the question again. Find the distance traveled by Azim in the second hour. Distance traveled in the second hour means from the first hour to the second hour. So that means it is modulus of S2 minus S1. So for S2, we sub 2 into the displacement function, minus S1, we sub t equals to 1 into the displacement function. Then we will have answer 125 over 12 km. For the second method, after we identify distance traveled in the second hour means distance traveled from the first hour to the second hour, we can do the working like this. T2 equals to integrate from 1 to 2 v dt. Because displacement function is not given, so to find the distance, you have to do integrate v dt. So this is the velocity function. We do integration and then sub 2 into the function minus sub 1 into the function. Then we have answer 125 over 12 km. Example 40. The diagram shows the movement of a car along a straight road starting from a fixed point O and heading towards point A and point B. Okay. The velocity of the car is given by V equals to 3t squared minus 16t minus 12. Given that the car is at point A when t equals to 5 and rests for a while at point B. That means at point B, V equals to 0. Calculate the acceleration of the car at point B. So at point B, just now we identify already, V equals to 0. And this is the velocity function. So I let 3t squared minus 16t minus 12 equals to 0. Okay, then we do factorization. We have answer t equals to 6. And then let's read the question again. They are asking acceleration of the car. So we have to firstly find the acceleration function from velocity function. From V to A, we have to do differentiation. So after we differentiate, we have 6t minus 16. So we sub the answer of t just now into the acceleration function. We have answer A equals to 20 meter per second squared. B. Calculate the distance in meter of AB. First of all, let's check point A. It is given by the question that the car is at point A when t equals to 5. Then how about at point B? Just now in part A, we already identified when V equals to 0, t equals to 6. That means the car is at point B when t equals to 6. So to find the distance of AB means you have to find the distance traveled by the car from t equals to 5 to t equals to 6. Since the displacement function is not given, so to get the answer for distance, you can do integrate v dt to get the displacement function. Okay, then the time is from 5 to 6. So we integrate from 5 to 6 v dt. So we sub the velocity function, do integration, and then sub 6 into the function, minus sub 5 into the function, then we have answer 9 meters. Example 41. An experiment is conducted to study the motion of a particle along a straight line with a velocity given by v equals to 3t squared minus 8t plus 4. At the beginning of the experiment, the particle is 2 meters to the right of O. That means this is the fixed point O. And at the beginning of the experiment, the particle is already here, 2 meters to the right of O. That means when t equals to 0, s equals to 2. A. Calculate the distance in meter of the particle from O when t equals to 5. To get the value of distance, we must firstly perform integration to obtain displacement function. So this is v equals to 3t squared minus 8t plus 4. S equals to integrate v dt. After we do integration, we have a plus c at the back. And from our analysis just now, we identify already when t equals to 0, s is actually 2 because the particle starts at s equals to 2. So we substitute t equals to 0, s equals to 2. Then we have answer c equals to 2. So this is the function of displacement. Then let's check. Calculate the distance of the particle at t equals to 5 from O. So at t equals to 5, the displacement of the particle will be, we just substitute 5 into the displacement function. And then from point O, at point O, at the fixed point O, s equals to 0. So that's why minus 0. So we have answer 47 meters. Okay. So for this question, please don't do S5 minus S0 because S0 answer is 2. S0 means the answer of displacement when t equals to 0. Okay, when t equals to 0, S equals to 2. They are not asking S0. They are asking from the position of O. And at point O, the S equals to 0. So that's why we sub 0 here. B. Calculate the minimum velocity of the particle. For minimum velocity, dv dt equals to 0. So this is the velocity function. Let's do differentiation. So dv dt, we have 3t squared minus 8. Then for minimum velocity, dv dt is 0. So 6t minus 8 equals to 0. And we have answer t equals to 4 over 3. That means when t equals to 4 over 3, the velocity is minimum. To find the value of minimum velocity, we have to substitute this value of t into the velocity function. So we sub 4 over 3 into the velocity function here. In the end, we have v equals to negative 4 over 3 meters per second. And then please do one more step to prove that the velocity is really minimum. So dv dt is 6t minus 8. Now let's do d2v dt squared. That means we differentiate this function. Then we have answer 6. 6 is a positive number, okay, greater than 0. That means you prove already v is a minimum. C. Calculate the range of time in seconds when the velocity of the particle is negative. So this is a direct question. Velocity is negative means velocity less than 0. So this is the velocity function. 3t squared minus 8t plus 4 less than 0. Then we do factorization. And since this is a quadratic inequality, so we have to do graph sketching method. Less than 0, that means we have to choose the region that is below the x-axis. So that's why the answer is t is in between 2 over 3 and 2. D. Calculate the maximum displacement of the particle from the point O for t in between 0 to 2. For maximum displacement, ds dt will be 0. So I write ds dt equals to 0, and ds dt is actually v. Velocity function is given, so we sub 3t squared minus 8t plus 4 here, let it be 0. After factorization, we have two answers for t. Okay. To identify which value of t will cause the displacement maximum, we have to do d2s dt squared. So ds dt is v, and it is actually 3t squared minus 8t plus 4. And now we have to do second order derivative, means we have to differentiate this function. So differentiate 3t squared, we have 6t. Differentiate negative 8t, we have negative 8. So we sub the value of t inside. When t equals to 2 over 3, we have answer negative 4. When d2s dt squared is less than 0, that means the displacement is maximum. So that means when t equals to 2 over 3, the displacement is maximum. So to find the value of maximum displacement, we have to substitute t equals to 2 over 3 into the displacement function. And this is the displacement function that we found just now. So after I substitute, we have maximum displacement 86 over 27 meters. Okay. Whereas for t equals to 2, if we sub into the d2s dt squared, we have answer positive 4. That means greater than 0. Okay, which means displacement will be minimum when t equals to 2. But the question is asking maximum displacement, not minimum displacement. So that's why we have to ignore this set of answer.